This lesson is going to give you an overview of considerations when visualizing social networks. The definition of visual analytics is a science of analytical reasoning facilitated by interactive visual interfaces. And it's a combination of automated analysis techniques with interactive visualizations to support effective understanding, reasoning, and decision making on the basis of very large and complex data sets. So its purpose is to enable insight discovery. The possibilities to collect and store data increase at a faster rate than our ability to use it for making decisions. And raw data can lead to information overload and have no value when it comes to human data interaction. Human data interaction, or HDI, is concerned with the increasingly pervasive data collection our lives are subject to and the way that it's opaque to most people. So, human data interaction can help cope with the big data and complex problems of connecting people with data through useful and relevant visualizations. These data collected about us and by us are analyzed by interfaces and about our personalities and behavior, and they're drawn from results and they're acted upon. So we propose placing the human at the center of these data flows and providing mechanisms for citizens to interact with these systems explicitly. Through intelligent information displays, we can attempt to create opportunities for improved decision-making capacity and for researchers and their audiences exposed to that research. So there's a number of tools that have been designed to aid you in your ability to effectively display social network data. And so we want to make sure that when we're producing a visualization for somebody or even in a publication, that it's not just somebody saying like, wow, you must be pretty smart because you made this amazing visualization. Instead, we want people to be able to make sense of it. So, a widely used network visualization tool is Gephi. It's a tool for people that have to explore and understand graphs, and it's like Photoshop but for data. And so users interact with the representation by manipulating the structures, shapes, and colors in order to try to reveal hidden properties of a network. And the goal is to help data analysts to make hypotheses intuitively by discovering patterns and then isolate structure or singularities in faults in data sourcing. And this is a complementary tool to traditional statistics. So visual thinking with interactive interfaces is now recognized to help facilitate reasoning. And so this is a software for exploratory data analysis. And so the paradigm for appealing in visual analytics and as a field of research. So Gephi is not only a computational tool that can be used to visualize your data statistically, because it's actually kind of superficial in the way that it does that, but it offers some real-time visualization that can be embedded into a website. And so it can support, at the time that I had put this lecture together, it could support up to 50,000 nodes and 1 million edges. Although the larger a network is, the more difficult it's going to be to interpret. So, if you have 50,000 nodes, you're not really uncovering patterns there. You're really going to see a big hairball. So it allows you to iterate through visualizations by using dynamic filtering, which can help create more meaningful sociograms by allowing more meaningful relationships to come to the surface. Layout algorithms in Gephi are also going to help you to shape your graphs. So force-based algorithms are a class of algorithms for drawing graphs in an aesthetically pleasing way. And their purpose is to position nodes of a graph in a two-dimensional, three-dimensional space so that the edges are more or less equal in length and there are few crossing edges as possible. So by assigning forces among sets of edges and the sets of nodes based on their relative positions, we're able to either simulate the motion or the edges or nodes to minimize their energy. And so while graph drawing can be difficult, or it can be a difficult problem, force-directed algorithms, being physical simulations, usually require no special knowledge about a graph or graph theory. So it's great to just be able to select those off of a drop-down menu. So multi-level graph partitioning algorithms work by applying one or more stages. So at each stage, it's trying to reduce the size of the graph by collapsing vertices and edges and partitions the smaller graph, and then maps it back and refines this partition of the original graph, which is why it can also be called graph coursing. So Gephi does some basic network statistics and metrics, but it can't really be used for advanced statistical analysis. And so for this reason, Gephi is more like the Photoshop, but for social network analysis, but it's for data. Dynamic network analysis, or DNA, brings together network analysis with time series data, so using time stamps on edges and vertices. A temporal graph with the GEXF file format can be displayed in an animation. You can also create cartography in Gephi by using ranking or partitioning data to make more meaningful network representations. Clustering and hierarchical graphs can be used to display social communities or network traffic. Finally, network filtering can be used to create complex filters that can be saved without any scripting, which is nice. So if you are scripting, there's a lot of additional resources that you might want to be aware of to improve network visualization. A tool that was created at Penn State is Color Brewer. It's an online tool designed to help people select good color schemes for maps and graphics. And so you can see here that you can select colors that are colorblind safe or printer friendly or photocopy safe. But it can also help you to select just aesthetically pleasing color schemes. You can also tell it how many classes of data you have, and in order to give some different options there. This is a hive plot. So this is a different type of node link diagram. It's intended to reduce those sort of hairball-like network visualizations, and it shows the dependency graph of the Flare visualization toolkit. So each dot here represents a class, and each line represents an import statement from one class to another, and where related classes share the same color. So this can sometimes be a way to iterate. If you have a very large data set and it's not showing something very meaningful, you could try a hive plot. You should also be aware that d3.js is available. It's a JavaScript library for manipulating documents based on data. So D3 helps you to bring your data to life by using HTML, SVG, and CSS. And D3's emphasis on web standards will give you all the full capabilities of modern browsers without tying yourself to proprietary frameworks. So you can combine some powerful visualization components and data-driven documents to DOM manipulations. So if you're unfamiliar with this tool, you can head over to their website and spend some time playing around with the tools. So the next two resources I'm going to mention are actually just textbooks. So Burton was a French cartographer and theorist and a world-renowned authority on the subject of information visualization. So this was originally published in French in 1967, and it's a book on seminology of graphics, and it's internationally recognized as a foundational work in the fields of design and cartography. So if you have an interest in data visualization and want to look at some seminal works or look at things that have been borrowing some of them since then, it can be useful to have that background if you're looking for literature related to information visualization. Again, if this topic really interests you, a second textbook that you might check out is The Visualization of Quantitative Information. And so this is a classic textbook on statistical graphics, charts, and tables. It explores the theory and the practice and design of data graphics and provides a ton of illustrations of the best and worst statistical graphics with detailed analysis of how to display it for precise and effective and quick analysis. So, the best resource for producing exceptional visualizations is to become familiar with the field available resources and just to try to stay up to date with new and innovative tools. So, just as a good writer tends to read a variety of work, a good designer and analyst is going to make it a priority to be familiar with the breadth of work available in this field. Okay, that concludes this lecture on SNA visualization.